In this video, we'll take a look at the Genero-supported data types. Refer to your documentation for specifics on each data type. This video instead gives you an overview and shows you some examples of using data types. A data type determines the internal format in which a data value is stored. It defines how data will be stored and managed, and it implies what operations on that value are valid. Genero supports a specific set of data types. In this example, we see 4 different variables defined, each variable given a specific data type, in other words, the way in which that data should be stored and managed. Let's take a look at these categories and data types. The first category is numeric data types. As you can see here, there are a variety of ways that you can store numeric data. From integer, small int, tiny int, and big int for managing whole numbers, to float and small float for managing floating point binary numbers, and decimal and money for managing numeric values with exact decimal storage. Now, the money data type is simply the same as the decimal, but will format as the currency defined for the system. In this example, we see 3 different variables defined, numeric variables defined, integer, money, and decimal. And you can see that both money and decimal require the precision and the scale. Then we're just taking those 2 values that we've assigned and adding them together. But we're going to store those in a money variable so that when we display that money variable, it will get the formatting of the currency for the system. And here the output would be $7,625.73. The next category is string data types, and string data types allow you to store character data. The first one, a char or character, allows you to store fixed length character strings, so you would determine the fixed size. Varchar, you'd also define a size, but it would be the max length, so this would be a variable length character strings. And the string data type is valuable because it's variable length, but also dynamically allocates the character string or the memory needed for the character string, depending on its size and without limitation except for memory limitations. Now, in this example, we can also see the benefit of a string because we have methods that can be used and applied to it. So in this example, we've given S a value of A, B, C, D, E, F with some trailing blanks, and then we're outputting the value and its length using getLength, and then we're trimming it, and if the trimmed version is the same, we are going to display that value but in uppercase. And as you can see here, the output is A, B, C, D, E, F, has length of 20, and then A, B, C, D, E, F in uppercase. The next category is date data types. There's date, date time, and interval for storing and managing values related to dates. The date data type is a point in time, like a simple calendar date. Date time is also a simple calendar date, but can also include times of day, or both date and time of day. An interval provides a way of storing a span of time, and the span of time can be in either years and months or in days down to small units of time. In this example here, we see 3 variables defined, 2 date time variables with the range year to month, and an interval data type year to month as well. D1 is being set to the current year to month, so we're using a predefined keyword current, which allows us to get the current system information, which is going to be the year to month, and then D2 is 1998 as the year and the first month. And then we're just going to perform a mathematical operation on those, subtracting the current, or the 1998 first month from the current year and month, and put that into our interval variable, and then display the span of time that has passed between those 2 values in the year to month format. You'll also note that you can apply built-in functions on date values. So here what we see is displaying the month of D1. So the month built-in function allows us to extract the month from that D1 date time variable. And you can use month, year, day, a variety of different built-in functions on those date and date time variables. The next category is large object data types. There's two types: byte, which is for large binary data such as images and sounds, and text, which is used for large text data such as documents. In this example, what you see is the text data type being used to define a variable called t, and we're retrieving from the database a file into that variable, which we have used the locate keyword to specify that it's going to be in the file /temp/mytext.txt, and then we're simply using another method at the bottom there, t.writeFile, to write that document out to another file, document.txt. You can use the free keyword to free up the space allocated for a large object variable. Now the last data type we'll look at is the Boolean data type, which is simply a logical value returning true or false. In this function, we're just simply checking to see the value of calls to two functions is valid and is stored, and if both are true, then our variable b will also return true, and if it's not true, then we're specifying that the order is not ready. So again, it just simply returns true or false, 1 for true and 0 for false.